Okay, so in this particular video, I hope to differentiate between the two terms, distance versus displacement. And I do want to point out that this is a one-dimensional analysis. So it'd be going like along a straight line, left and right, or up and down. But I'll just go ahead and stick with examples going left and right. So you can use the same concept if the problem happens to be changed to a vertical north and south. Okay, so the first example here, I have a butterfly. As shown here, its initial position is at a positive 4 meters, and then it's going to fly straight leftward to a position of -3. All right. So the first question I have here is, what is the total distance covered by the butterfly? And this is pretty straightforward. It went from a +4 to a -3, which is 7 units. In this case, each unit is 1 meters. So if you want, you can count. There's 1, 2, 3, 4, 5, 6, and 7. So that's the ending point. So the answer for the total distance would simply be 7 meters. Distance is a scalar quantity in physics. There is no need to provide a direction. It is a scalar quantity, so just the absolute value of your measurements. Okay, so in this case, it went 7 meters to the left, but you don't say left, you just say 7 meters. All right. The next question here asks you, what is the total displacement covered by the butterfly? Displacement, on the other hand, it is a quantity classified as a vector. Because it is a vector, it must have a magnitude and a direction. So in this case, to find total displacement, you would simply draw an arrow from start to finish. So since you start at a +4 and you end at -3, draw an arrow towards the direction of motion. So in this case, the butterfly flew to the left, so the arrow should be pointing to the left, and the magnitude of that purple arrow should be 7 units. That's what we counted. Okay, so the way to express your answer here would be 7 meters to the west, or 7 meters left or leftward, whichever wording you want to use, or you can simply use a negative sign to indicate that it head towards the left. So any one of these three responses would be sufficient. Okay, the third bullet point asks you for the magnitude. So as you practice, it's important to pay attention whether the word magnitude gets used or not. If a question uses the word magnitude, you simply leave out the direction. Magnitude simply asks you to just give the value and the unit without the direction. So in this case, we know the displacement from our previous work is 7 meters west or 7 meters left or -7. But this is the magnitude. What I'm circling with my cursor, that's the magnitude. It's just 7 meters. Okay, so our answer here would just be 7 meters. So magnitude just tells you leave out the direction. Mathematically, total displacement is delta x, which is equal to the final position minus the initial. So if you want to follow math functions, that's fine too. You can plug and chuck. The final position here for the butterfly is -3. You would subtract, and then the initial position is a +4. So if you do -3 minus a +4, that will give you -7 meters. But however, if the question asks you for magnitude, you just cross out the direction, so therefore your answer would just be 7 meters. Okay, all right, let's do another one. All right, in this particular one, we have a bee, its initial position, and position is a vector, so it's going to be +5, and it's going to fly all the way to -6, and then it's going to turn around and fly back to a final position of -1. Okay, so the first question asks for distance or total distance. So easy to do. You count everything. Whether the bee flies left, right, doesn't matter. Just count everything that pertains to that particular motion. So let's go ahead and count really quick. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And then again, it turned around. So it'd be 12, 13, 14, 15, and 16. So the bee in this case has flown a total distance of 16 meters. Okay. And then the second one asks you what is the total displacement. Again, it started at a +5. It flew all the way to -6 and then back to -1. But displacement doesn't really care for the path of motion. It only cares about your starting point and your ending point. So really all you're asked to do is just draw a straight line that connects start to finish, nothing else. So if you start at 5, you end at -1, you would draw an arrow from start to finish. In this case, it also points leftward. Okay, and if you count the length of that purple arrow, that will give you the magnitude. So in this case, from +5 to -1 should be 6 units. And so it'll be 6 meters. It's west because the arrow is pointing to the left. Or you can say 6 meters leftward. Or in this case, because it's pointing leftward, you can just use the negative symbol to express the same information. Okay. If it asks for magnitude, simply type in 6 meters. Leave out the direction. So that's that. So the word magnitude tells you leave out the direction. All right, let's do a third example for a one-dimensional analysis here. So here you have a car that starts at a +2, and we can keep everything in units and meters along the number line. It's gonna drive all the way to a -4, and then from -4 it's gonna drive all the way back to a +6. Okay, so in this case, to find total distance, we would add every single step that is taken. So from +2 to 0, it is a distance of 2. From 0 to -4, it is a distance of 4. So you notice I said distance of 4, not -4, because distance is a scalar quantity. Even though the car is driving left, distance cannot be negative. It's just whatever ground that's been covered. Okay, so far we have 2 and we have 4, which is the distance of 6. And then from 4 back to 0 is another 4, so that'll be 10. And then from 0 to 6 is 6, so 10 plus 6 would be 16. So therefore the total distance traveled was 16 meters. And then the total displacement, without the word magnitude, just the phrasing the total displacement would imply that you're looking for a vector, which means you need to give the magnitude plus the direction. Okay, so if we do that, we again just care about 2 points, your starting and your ending point. It started at a +2, it ended at a +6. So just draw an arrow from start to finish, a straight line, and that particular purple arrow is 4 units because from 2 to 6 is a difference of 4, and then it's pointing to the right. So your displacement would simply be 4 meters east, 4 meters rightward, or +4 meters. And if the question asks you for magnitude, hopefully by now, you simply just state 4 meters. Okay, or if you like to use the math function, delta x again is xf minus xi. This is a one-dimensional analysis, I remind you, so you can apply this function here in a one-dimensional analysis. Okay, final position would be a +6 minus your initial position would be a +2, and if you do that, you get a +4 meters. But if it asks for magnitude, just mentally cross out the value, the direction in front of the scalar. Okay. All right. I hope that helps. Good luck. Don't be whack.